So Johnson Labs at this point is 9 years old, focused on at this point on medical language models, big and small, and serve the majority of that community. But Johnson Lab is still most well known for the Spark NLP open source library, and that is the first topic we are going to talk about. Spark NLP has recently crossed 120 million downloads, and is still being used at a rate of about 4 million downloads per month. So still very widely used across the ecosystem. For 5 years in a row, it was the most widely used NLP library in the enterprise, based on kind of the annual O'Reilly international industry survey. And really, it started as kind of as a scalable library based on Apache Spark that implemented more than 100 different NLP algorithms and tasks. One interesting thing that many people may not know is that really in the past year, since the 5.0 release, the growth in downloads has been just over 60%. And actually, the rise of LLM and RAG pipelines actually caused a huge spike of interest in Spark NLP, because as you'll see now, it actually handles some of the major scaling issues in building RAG pipeline or doing LLM inference and scale, and we'll talk about those use cases. The other thing, that there's still a very active community, so we are just now celebrating 8 years with releases every 2 weeks, and actually I'll share a bit about the recent major release that happened just last week. So first of all, Spark NLP is open source software under the Apache 2.0 license. So anything that will be shared here is completely open source, including for commercial use. There are more than 100 different kind of tasks that the library can do, and it's grown really beyond the classic NLP to do things like speech to text, image classification, of course, text generation with LLMs, summarization, question answering, translation, and many other tasks. Right now, there are more than 90,000 models that are available to you, including all the latest and greatest LLM, and you'll see some examples. So honestly, the list of models here on this slide, looking at BERT and Elmo and T5 is greatly outdated. Of course, all of those are there, but you should also know that you have Qwen and Llama 3.1, right, and Phi and other other LLMs from this space. Spark NLP has always been targeted towards kind of the larger at-scale enterprise deployment. As such, it has integrations and optimizations for, I think we're still at kind of 13 platforms that we officially test each release for. So first of all, of course, you don't have to run it on a cluster or at scale. You can run it on your own machine, within a Docker container, on a Colab notebook, on Jupyter locally. If you want to scale, you can scale it on anything, Amazon EMR, Databricks, Snowflake, Google Cloud, Azure, Oracle Cloud, Kubernetes, really pretty much any popular scaling platform for analytics products. And we also have integrations with some MLOps tools, right? Notably MLflow and Comet. This course, these next 2 days, is not a course about Spark NLP, because the focus is to give you really a more general overview about generative AI, right, and all the tools available to you kind of within that ecosystem. If you're specifically interested in knowing Spark NLP in depth, there is now a Udemy course for that. That's a fairly popular course taught by several of the contributors and developers of the library itself. So if you just go to Udemy, Google it, Spark NLP for data scientists, that's all there. You have videos, you have exercises, you have documentations, and that's kind of become a popular way to learn the library. One important thing to know about Spark NLP, and you'll have an hour specifically about it and about how to define pipelines later today, is that at this point it's become basically the only alternative kind of to the Hugging Face ecosystem in terms of how algorithms are implemented, in terms of name recognition, text classification, right, question answering, translation, and within Spark NLP, we have our own implementation of this code base. It is natively scalable. and really for many use cases, still the only library that that scales nicely on commodity hardware. And of course, we work closely with Intel, NVIDIA, and Apple to optimize the software for their specific hardware. When we talk about generative AI, within kind of the new type of use cases that have emerged in the last 2 years, one of the questions that we often get about Spark NLP is, look, why, like, do I still need a traditional NLP library now that I'm doing anything with LLM and RAG? And the answer is, the answer that has really emerged from the open source community is that there are 2 use cases where this library seems to apply itself very, very well. The first one is when you are building a RAG LLM application and you're looking to populate a vector database. So let's say, for example, that you're looking to build an application where there's this front-end LLM that acts as a chatbot, and let's say that you want to ask a question about, for example, all of PubMed, all of medical resources, right, or all of the emails within your company, or all of the public legal precedents or regulatory guidelines, right, in a given area. So the way RAG works in general is that you take the documents, you calculate embeddings. So usually, first of all, there's more than that. You split the documents in a smart way, right? Sometimes you have images or tables to deal with, but at the end of the day, you take a paragraph or sections, and from the text you calculate embeddings. You store them in a vector database. And then when an end user has a query, you maybe do some query transformation, but at the end you translate the query to an embedding model as well, and you send it to the vector database. And the vector database basically only has one trick. Given a vector of embeddings, so a vector of numbers, really very quickly find the 10 most, 50 most, 100 most semantically closest documents to that query, which really means that the query, the embeddings, find the documents with embeddings that are closest to the embedding of the query. Okay, so for example, if I'm looking for research about the outcome of a specific operation, for example, a specific surgery, right? If I build my vector database with the right embeddings, right, I should be able to find documents, right, or titles that talk about outcomes of a specific surgery, return it, and then the LLM puts together kind of a nice answer with the context that was returned. The challenge here is how you calculate those embeddings and how you input them in the vector database at scale. And that is something that you often have to do over millions of documents, which is why, if you look at really many vector databases, many applications, really this is one of the things that in general people find does not scale well, or becomes very expensive to scale if the answer that you're getting, yes, you need to buy a very strong H100 machine, right, just to be able really to calculate embedding and load the database. And instead, what you would want, especially if you're dealing with, say, tens of millions, right, or hundreds of millions of documents, is to be able to scale this cheaply on commodity hardware. That's one thing. The other thing, really, you just want to do it faster. Today, basically, every implementation is based on Hugging Face, right? So if you're using Haystack, right, or if you're using LangChain, if you're using Llama Index, at the end, the embedding calculation is usually done that way. What you can see here, if you use the Spark NLP implementation, and this is not scaling on the cluster, this is on a single machine, you're going to be really between 3 times faster for kind of most embeddings to 6 to 7 times faster if you're using quantized models, quantized embeddings, compared to Hugging Face. So this is the difference you should see on a single machine, right, without scaling. And this really was just done just by really building a truly different implementation, right? This is optimized, heavily optimized, and really just done in a very different way. On top of it, not only are you going to run substantially faster on a single machine, you can also scale pretty much linearly with no change in code. And what you can see here in this example on Databricks, where you can see the performance, basically the speed, right, it took to process in this case, a data set of 50,000 documents, 100,000 documents, and 1 million documents using a single node, right? So for example, the 1 million, that took about 2,500 seconds. But you can see that just by adding workers to the same cluster, and that was the only change, the configuration change, no code change was needed, you can get it down basically by to be an order of magnitude shorter, right? And here in this specific example, and if you're interested, the code itself is of course open source and public. Processing of 1 million document really went from 43 hours to 3 minutes. Okay, and this is on commodity hardware, right? So this is basically staying with cheap machines and scaling horizontally, and of course you can do this also on demand, right? Either on Databricks or any of the other cloud providers. So that's one use case that the open source Spark NLP is still uniquely set up to provide you. So if you're looking to populate the vector database, and really you need to handle millions, tens of millions, right, billions of documents, or you need to update them on a regular basis, that's going to be by far the faster and cheaper way to do that. A second use case in which we see a lot of interest in Spark NLP is LLM inference at scale. And when you do inference, sometimes really you just want an API endpoint and kind of, you send the prompt, right? Tell me a joke, right? Draw me a ship, and you get an answer. But sometimes you are looking to do this on a large batch in scale. So for example, what if you have 10 million or 10 billion documents and you're looking to translate them? Okay, so you have these documents in a database, right, or on a folder in some cloud, and you're looking to translate them from one language to another, or you're looking to summarize them, or you're looking to answer some questions about them. Okay, so this can happen a lot if you, for example, you're looking at a large body of academic research, large body of legal precedents, large body of contracts, right? If you have loans, right, service agreements, NDAs, you're looking to summarize, answer questions, and so on. And you want to do this as a batch. What Spark NLP enables you to do is same thing as it enables you to do with any other task, is simply call LLM inference as really just one more step in a compute pipeline. So just like you can come and say, oh, I want to tokenize this, or I want to do text classification or name entity recognition, you can also say, oh, run this prompt, okay, as one step in a text processing pipeline. And like everything else in Spark NLP, this is natively scalable. So now also you can scale it horizontally, right, on commodity hardware, and really make it basically as fast as you want that way. So here you can see an example with specific Llama 3.1 8B instruct, which is only kind of one of the models that's there. And as you see today within Spark NLP, when we talk about an NLP pipeline, there's an actual pipeline class, and we'll hear more about it later today. As you can see, you can configure prompts, you can configure batch sizes, temperature, right, and any other parameters that you need, and of course run this efficiently. So at this point, the 5.5 release that happened last week, which was really a big effort by both our team and the community, added tens of thousands of additional GGUF models, basically natively within the Spark NLP ecosystem. And this includes really all of the current kind of widely used open LLMs. So of course the Llama ecosystems, the Qwen ecosystem, the Phi ecosystem, and several other embeddings and model types. There are also optimized builds for Intel, for NVIDIA, and for Apple hardware. And there's native integration with Llama CPP, which makes it very easy for us to basically to get new and support new model architectures as they come. So at this point, everything that Llama CPP would support, basically a few years later, is going to be supported within Spark NLP as well. We've also imported a model, so we've imported, I believe, more than 50,000 new models into the NLP Models Hub at this point, which is basically the majority of the models that people actually use. And within the Spark NLP Models Hub, the approach has always been have somewhat of a curated experience. So we don't take everything that's in, a Hugging Face. We take things that are, that are reasonably tested, right, usable, safe, right, so that we can have more of a curated experience of models that we know would work. If you're running batch LLM inference at scale, so yes, you can scale it, but one very important point is that you're also going to see much better performance on a single machine. Because as I mentioned before, this is its own separate implementation. So if you see it here, this is a benchmark done on a single server, so single M6 ID 4x large. So this is an Intel machine. It's not even a GPU. 64 GB of memory, right? So not a kind of not a large machine or an expensive machine by any point. And really, all we've done here, we run this on 100 rows of text. Okay, so this is not an enterprise-grade large-scale deployment. This is something very small. But even here, you can see how long it took to actually get an answer, right, from the LLM. So if you look into do LLM inference, where we see people adopting Spark NLP is first of all really where they just want the speed, right? Even if it's just an API on a single machine. Definitely if they need something to run at scale. And another thing to consider, what's on this slide, is also the cost, right? So if you're looking, for example, to summarize, say 1 million regulatory financial document, financial disclosures, right, insurance summaries, social media posts, whatever may be the case, one of the first questions you get from your own team will be, okay, how much is going to cost us really just to run the thing? And so far, really, because of how fast the software runs on a single machine, which is basically best in class in the open source ecosystem, as well as how easy it is to scale it on commodity hardware in terms of buying more expensive servers. Right now, what we are seeing is that this is by far the cheapest option to run LLM inference at scale if you do need to run it right in batch mode. And this is very important because the cheaper you can do this, right, the more projects actually become economically viable and have a positive ROI. So we're going to cover a bit more detail about the open source Spark NLP, and you'll get kind of one session that's going to be an overview of that. After that, we're going to talk a bit about multimodal generative AI, and specifically, we are going to focus on visual document understanding. So multimodal AI usually refers to cases where you have to answer questions using more than one modality. Right? For example, here, in this example, in order to answer the questions correctly, you need to be able to read. So that's the text and NLP part, but you also need to be able to see and understand visually what's happening. So what we're looking for is an out-of-the-box model that will look at the image on the right, and this should be available just as a scanned image, and then be able to answer the questions like, when is the coffee break? And that's it. We just give that string as a prompt, and we should expect, oh, the coffee break is from 11:14 to 11:39. Notice that if you look at the image, it doesn't say that this is an event and the coffee break is happening within those times. What we would expect the pre-trained model to know is, look, when you look at this image, it's obviously an agenda of an event. Okay, in an agenda in event, very often you have this two-column thing where you have the timeline of the event on the left and the description of the event on the right. Therefore, if you're asking when is the coffee break, yeah, just just look at the left, right, and and there's your answer, right? And that should be without any pre-training, without tuning. It's kind of this common sense, visual understanding, right, of how, in this case, of how agendas are usually published to people. Similarly, who is giving the introductory remarks? I mean, it does not actually say that on the image. We expect the model to know that, look, if you have something that looks like a person name after a title, then that's probably the speaker of that session, right? Because that's how it usually works. So in order to do that, the model, of course, needs to be able to read English, right, and understand language, understand the questions, but it also needs to see, right? And of course, this is also a computer vision algorithm, so it understands really where things are placed and what it semantically means. These kind of algorithms can also do things like parsing invoices, parsing lab reports, right? Understanding documents, understanding signature, and you see more examples. A very common use case for visual document understanding is understanding forms. So for example, looking at the image on the left, right? And it can just be given as a scanned image. And with forms, usually what you're looking is to extract a specific structured data, right? So this is some kind of a patient report. So we want to extract the patient's name, the patient's number, right, their blood pressure, their date of birth, their gender, their height, and so on. And of course, this could be a tax form, a college application form, right, a loan application form. Doesn't matter, right? The point is that what you do not want to do is first use OCR to get the text out of it, because once you OCR it, you're going to lose all of the visual information, right? For example, the fact that the name, it's always in the top left, right? And blood pressure, it says BP and is always in the top right. Usually once you OCR things, you lose that really sense of really where things are, are they in bold or not, right? All those visual hints that we use as people to read those things quickly. And what we have now is we have multimodal models that basically are OCR free. That's the term that people have started using, and will enable you to more, because of that, it will enable you to more accurately extract information, right? Because they use both visual signals and the ability to read and understand language. A third kind of use case within kind of our visual NLP, visual LLM models, is table extraction. Table extraction is also very popular in life science, in insurance, in finance, in healthcare, right? Even in regulatory and commercial applications. You have documents. Within the documents could be embedded one or more tables, and the tasks are usually, first of all, look at the image on the left and detect that there is a table here. That's task number one. Task number two is split the tables into rows and columns, which is sometimes hard because, as you can see in the example here, sometimes you have some borders, right, visually, but not elsewhere. Sometimes you have missing data. Sometimes you have footnotes. Sometimes people use pivot tables, right? But the goal is to come and say, look, just visually understand how this table is, and what value should belong in every cell. And once you do that, the last task is, okay, can you actually extract it to, for example, like a Python data frame, so I can put it in a database and run calculations on top of it. As you'll see, there are models that are designed for a very large variety of tables, and there's a lot of ways to visualize tables that enable you, that give you those answers. So all of this will present as part of the visual NLP library. So we will go over that. After visual NLP, the kind of last big section of today is going to talk about our healthcare NLP and LLM models and libraries, which is extension of the open source Spark NLP, but really it's a different code base. It adds tasks like relation extraction, entity linking, de-identification, medical text summarizations, data enrichment, and it also comes with actually more than 2,400 healthcare-specific pre-trained models that Johnson Labs has built. And this is going to be really, it doesn't matter what industry you're at. One of the important points here is that very often domain-specific language models are going to outperform general purpose LLMs, and you see multiple examples of that. A lot of the focus in building the healthcare model is really just accuracy, right? Just looking at very specific tasks and seeing, okay, what actually is the state of the art in terms of accuracy for these types of summarization, question answering, entity recognition, right, mapping to standard codes, and really picking the right model architecture and right model type to achieve state-of-the-art accuracy for each one. One of the results of that effort is what you see here on this slide. If you compare Johnson Labs with AWS Comprehend Medical, Azure, I believe it's called now Document AI for health, and Google Cloud Healthcare NLP API. Also, all of these benchmarks are public. And by the way, in general, whenever you hear a benchmark from me or anyone else this week, it means that it's either a public peer-reviewed paper or that you've made the notebooks, the data, and the code public so that you can reproduce it yourself. We also give the software for free for academics so that they can reproduce it for you, right, and build on top of it. But look, the bottom line is, you're going to see 4 to 6 fewer errors on the standard information extraction tasks, entity recognition, de-identification, mapping to standard codes. There's also a set of newer 2024 papers that compare to more kind of newer LLMs. Mostly we compare to GPT-4 and recently to GPT-4o to see really how we're doing in terms of accuracy. So for example, one of the examples is one of the papers we've published is around extracting social determinants of health from clinical records. In general, social determinants of health are things that impact your health, right? How well and how long you would live, but are not classic medical diagnosis. So this is not about, does someone have, asthma or depression or diabetes? This is more about, do they have a home, right? Or are they homeless? Do they have access to care? Do they have health insurance? Are they in a stable relationships? Do they have a job? Do they have a good social support system, right? If they get sick, are they exposed to violence in some way, right? So these social determinants, obviously, they're not technically medical diagnosis, because they have a huge impact on people's health. So it's interesting to extract them for medical content. One of the things that also we have to say, this is one slide. You're welcome to go through the whole paper and the code behind it if you're interested in the details. But in general, one of the things we've done after a fairly thorough examination, right, and prompt engineering, is that GPT-4 makes 3 times more mistakes the models we currently ship for extracting really the most common social determinants of health from clinical notes. And really, this is just one type of this kind of information extraction. If you're looking to go beyond recognizing entities and also mapping entities to standard codes, okay, so in healthcare, you would look at things like ICD-10-CM or RxNorm or LOINC or MESH or UMLS. These are, for example, things that LLMs are really not designed to do, and you'd want really a different kind of solution architecture, different model architecture to do that. And you can see the really fairly major differences here in terms of accuracy. Another interesting task that is definitely something you would do in an LLM is medical text summarization. And so the title, there's a typo, it shouldn't be medical test, it should be medical text. This is a benchmark that we conducted because, of course, you can summarize, in this case, right, a medical note in different ways that would be kind of just as valid. So what we've done here is we've conducted a blind test where we let models. So yeah, I think we've done it with one of our models, an 8B model. We've done it with GPT-4o just last month. So really kind of the best and most recent model that's available from OpenAI. And what we've done is we asked both of them to summarize clinical note, and then we presented this to practicing medical doctors as a blind evaluation, right? So the evaluator does not know which model wrote that summary, and they're asked 3 questions. They're asked about, first of all, correctness, right? So are there hallucinations here, or are we summarizing correct facts from the text? Clinical relevance, so basically, is this kind of a correct summary, the correct way to summarize what happened here, and are you not missing any critical details? And the 3rd question is around conciseness, right? So assuming you're telling me the truth and you're telling me all the clinically relevant kind of important things to put in a summary, how short this is. And as you can see, we have models, not only that the models are preferred almost on a 2-to-1 basis, twice as often to GPT-4o. We also do this with a model that's only that only has 8 billion parameters. Okay, so not only can you have models that are really more accurate for specific domains and tasks, they can be much smaller while they do that. This means that you can run them within your firewall. So when you run them, you don't have to call an external API. and it means it's going to be far cheaper to do this as well. One last task that we'll discuss in depth later this week, where also there's a recent 2024 peer-reviewed paper that shows a comparison for is text de-identification. So with text identification, what you do is you take the input is the text on the left, right? That has some personal information about the person, and the first thing we do is we detect the what's called PHI, personal health information. So we want to make sure we detect all of the names of the patient, the dates, patient numbers, addresses, and so on. And then either we can mask them, or in this case, we want to obfuscate them, right? So we replace John Doe with Jack Michaels, which is a made-up name, right? We shift all the dates, right? In this case, I think by 12 days, we change the doctor's name and so on. So here also, we have a recent peer-reviewed paper that shows that the current system we have makes 50%, 475%, and 575% fewer errors than the comparable AWS, Azure, and GCP services, and it also outperforms GPT by 33%. Okay, so and by GPT we mean by ChatGPT we mean GPT-4, and we have a system that basically exceeds 98%, meaning it exceeds human expert capability in across 7 languages. So this is going to be the final session of today, really talking about healthcare, but more generally about domain-specific models, because one of the things that you can see very, very consistently in industry, in the literature, also in some of the current trends between kind of the ongoing battle between small language models and large language models, is that domain-specific LLMs would usually, kind of if built correctly, outperform general purpose ones. And there's a lot of work kind of in the industry around that. And of course, our focus is in healthcare, but there are people working on finance, on insurance, on architecture, right, on academic research, on legal, and so on. So that's today. The second day is going to focus on 3 other kind of parts of the generative AI ecosystem. The first session is going to be around the chatbot. So within Johnson Labs, first of all, we train and we use our own medical large language models, and not only that, as anything, our goal is to provide the community with state-of-the-art results. So, for example, on the Open Medical LLM leaderboard that Hugging Face published with some partners, the benchmark that they have done there, and this kind of benchmark that they've built and they have the code for and they run, you're looking at an average of 9 separate benchmarks. And these are classic things like, for example, answer how well can you pass US medical licensing exams? How well can you answer college level questions, right, on your biology, anatomy, genomics, right, college medicine? How well do you pass Indian licensing exam? How well do you understand medical research? On that benchmark is really an average of 9 different challenging data sets. Right now, we have the best number that's been kind of publicly reported on the data set. As you see, significantly beating things like MedPalm 2, things like GPT-4, and kind of the current Llama 3 ecosystem. But on top of that, what's important is, first of all, yes, we have the LLMs. We can license and provide them for different use cases. But we've also we've built an actual chatbot application. And what's unique about it is that really it's designed specifically for a domain, right? And that does not just mean that it has domain-specific LLMs that will give you higher accuracy answers. It also means that it handles kind of the compliance and privacy requirements that are there. So first of all, it runs privately behind your firewall, so it will not send you questions to any external API. Not an OpenAI one or an Azure one, but also not a Johnson Labs one. So everything can run air gap within your premises because the LLM is deployed there. It will not hallucinate because what it does, as you can see here in the example, is that it provides, it cites its reference basically for every claim and every sentence that's there. and we check that those references actually exist. You can click reference and go to the source document, right? If you don't believe it, or if you want to check or dive in deeper. All the medical knowledge is updated daily. Okay, and you can add your own private knowledge bases, right? So for example, you can come and say, okay, I understand you give me the full medical knowledge graph, right? All research, all ontologies, all clinical trials, that's great. But I also have my internal confidential documents. Can I also ask questions about that? So yes, you can do that. You can add your own private medical knowledge bases. You can decide which groups and users are allowed to have access to them. And also how you should answer certain questions, right, in terms of guardrails, right, and really limiting what you want to allow people to speak with your chatbot about. So that's one thing that's available to you as well. And you'll hear more tomorrow about kind of a bit about the architecture. So there are multiple LLMs that are involved, right? There are multiple knowledge bases that it comes with. This solution basically comes with its own RAG backend, so that you don't need a separate kind of RAG architecture. And we'll also talk about kind of the overall enterprise deployment form for the chatbot. So this would be useful for you, either if you're interested in this, or even if you're building your own chatbot, to really understand the gap between what you can get kind of with out of the box, right? Vector database, RAG infrastructures, chatbot solutions, and what is really required kind of for a high compliance enterprise grade solution that's been deployed today. Another thing that we'll talk about briefly tomorrow is document Q&A, which enables you to, in this case, you see, load a set of documents. And of course, you can do it through the UI. You can also do it through an API, and understand all of them together to build a timeline. So for example, in healthcare, one thing that you often need to be able to do is build a complete view of the patient over time. Okay, so I have a patient, but maybe I have 200 documents about that patient, because the cancer patients, I've been seeing them for the past 3 years. And then I want to ask questions that require inference across this timeline. And one nice thing that LLMs can do is they can provide that level of inference, and they can explain their logic. Okay, so for example, here you can see here, I asked a very simple question: what is the age of the patient? Right, so we uploaded some document about some patient. We just ask a super simple question: how old is the patient? And the response is interesting, because you can see some of the reasoning capability of this medical LLM. So you can see the patient's age cannot be derived directly from the provided documents. There's no explicit mention of the patient's birthday or current age. So basically, the documents do not say how old this person is. However, right, it can be inferred. So for example, according to document number 1, and of course this, you'll see, you can soon see, you can click on it, the patient was born prematurely. According to document number 3, the baby was observed with signs of apnea of prematurity. According to document number 4, the patient's weight at discharge was 2,110 grams. Therefore, based on this, you can safely assume that this specific patient is a premature infant, right? Probably likely age between 28 and 35 weeks, right? And then, as you can see, you can click the documents, right? And you can see where in the source document, right, each piece of information came from, right? And you decide if you agree with it or not. But this is one thing that now you could do with the chatbot, you could do with LLMs in general. Not only extract information, right, to point, oh, if it says that this is a 6-month-old baby, okay, extract that. You can also really make kind of common sense inferences, and in specific domains like healthcare, you can also make medical inferences, right? So that's supported here as well. So that's going to be session number 1. We're going to talk about the medical chatbot, how you build your own enterprise chatbot with private knowledge bases, and how you can build views of the patient over time. Then the next session is going to introduce really more the developer perspective of the Generative AI Lab. So Generative AI Lab is a no-code platform that enables you to look a document, run LLMs or other rules, prompts, models on top of them that extract information and answer questions. Okay, so for example, if you're looking to for example, read regulatory filings, right, of companies, and find specific examples where, for example, they're issuing more equity, right, or they're issuing a warning, right, and they're trying to bury it within a very long document. So this platform would enable you to load in those documents within a no-code UI, would enable you to define what entities you want to extract, what do you want to classify, what questions you want to answer. Usually you have a model kind of pre-train it, and then humans can go and fix the model. Okay, so this is good for, this is basically a very useful tool nowadays for either for training and fine-tuning models or for human in the loop. There's going to be a whole day of this tool this Friday, but tomorrow what we're going to have is really just 1 hour to look at the highlights and specifically how developers can integrate with this tool to build complete solutions. So the Generative AI Lab used to be a cool tool called Wayback and the Annotation Lab, because the old school use case, I would say 3, 4, 5 years ago, was that when we trained an NLP model, we need to annotate data, right? And then let's say we train a model based on BERT, right, or one of those one of those embeddings. So we would define the task, for example, like here, for example, if you look at this image, you say, okay, I want, this is a clinical note and I want to extract, treatments, problems, tests, drugs, dosage, frequency, and route in which how you take this drug. And then you load some sample documents. You have a human expert annotate the data, right? So give you basically enough examples. And of course, you want the system to, keep an audit trail and a versioning, right, and have security and have a work queue so that you can share those annotation tasks across a team of people. And once you believe you have enough examples, you want the system to, you want to click a button and have the system automatically go and train a model for you. Right now in the LLM world, there's less interest in this kind of, okay, do I really need to annotate a lot of data just so that I can train one model that does one thing? Instead, kind of just give a prompt to an LLM and see how well it does out of the box. And when you're leaving that model, there are really 2 specific use cases that the Generative AI Lab is really evolved to support. One is using an LLM to bootstrap a task-specific model. This means that what you do is, let's say, for example, you want to extract, say, patient safety events, right, from reports of patients being in hospitals. What you do is you write prompts with an LLM. You will load some sample documents. You will tell the LLM, okay, go, just do it automatically from scratch. The LLM will do it, and of course you can do it without coding within the tool itself, right? As you'll see, by defining a project. But then what you'll do, you'll have human experts go to basically check and correct the LLMs. Once you're done with it, you'll have the system train a model, and now that's going to be a small model that is task specific. Okay, and the reason you'll want to train a small task specific model is, first of all, it will likely be in many cases more accurate than the LLM. That's one. The second thing, at that point, especially if you're relying your LLM is something that you pay for, like an API, right? So let's say you're paying, Cohere, Anthropic, OpenAI, Mistral, right, for API calls. Once you've trained this model, that's it. You own that small models. You no longer need to pay for inference. Okay, so we see this happening very often. You use an LLM basically to bootstrap the training data, so you do not need to annotate a lot of data. Maybe you go through it and kind of validate it, but the key thing is at the end, you train your own small task-specific model. So that's one common use case that we see nowadays. Another common use case is really just human-in-the-loop workflows. Okay, so let's say that you need to extract information, say from regulatory filing for clinical trials. You do want to use an LLM to extract the information. But because LLMs are not perfect, right, and sometimes they make mistakes, then your workflow is, okay, read a 300-page PDF, answer those questions, right, or extract the information, do all of this automatically, but then please put it into a user interface so that my human experts can go in and really just validate whether it is correct or not. Okay, to do it, of course, you want work queues, you want a very high productivity tool where within kind of just a couple of keystrokes, people can come and say, no, it wasn't this, it was this other one. And then also kind of the versioning and audit trail, right? So really at the end, you have regulatory grade output of how this data was created. So you'll see examples of how this is done, both through the UI and through code. Tomorrow the focus will be on the code. On Friday we'll have the we'll focus on the kind of on really how domain experts who are not software engineers or data scientists can do this. So as I mentioned, one use case we'll cover is using LLMs to train small task-specific models. Okay, so you define the prompts, you load the data, have your LLM, right, the large language models pre-annotate. You have a human expert go check and correct what the model did, and then really you have those nice corrected examples, and the system will automatically for you train a small language models. That just does that, and then you can just take it and do inference privately, cheaply, right, at scale. When you are building human in the loop pipelines, of course you want the user interface, right? You want user management, project analytics, versioning, workflows, reviews, and all of that. But sometimes, very often, you also want API integration, right? Because your kind of says, look, whenever whatever a new invoice comes, we have a model that automatically extracts data from the invoice. But then I wanted to call some API and just put it in someone work queue, right? For example, right, to look at this and check if this was extracted correctly. So hopefully they spend exactly 10 seconds on it. They just check and everything is correct. If not, they need to correct one or two things, right? That are maybe the algorithm misses sometimes, and then right we can go and say collect the money, right, or pay the money or whatever needs to be done. So to do that, you'll want API integration, right? So that every time you get a new invoice on an email, right, you can create a project, right, add the task to a work queue, right, and so on. And also once the human expert has done the work within the tool, you want to be able to have an API call and says, okay, give me please, right, all the entries that have been reviewed and approved for publication, right, and then you take them to a downstream system. So you'll be able to see how that is done. The last session tomorrow is going to be about responsible AI. Until very recently, and in some cases this is still happening, a lot of the focus was really most of the focus on comparing and evaluating models and LLMs is around accuracy, right? And that's usually what people care most about, right? So if you tell me that you can automatically translate this text to Japanese, my first question is can you really, right? Or how well do you do it? But when you are deploying systems to production, accuracy is not enough. You need to make sure that your models are safe, that your models are not open to attacks, right, from toxicity to sycophancy, right, to different types of prompt injection. You need to make sure that the models are not biased and the models are fair and robust. And while maybe even I think the last time we had this training back in July, this was all yes, you should do it. It really is a best practice. What's happening right now very, very quickly is there are more and more laws that are already on the books that require you to do this. So for example, if you're doing anything in healthcare, it's basically at this point, it's illegal to have models that bias, that show bias based on gender, age, disability, national origin, race, or ethnicity. This is similarly the case if you're doing anything in employment. For example, if you have an LLM that matches, say, resumes from people to job descriptions, you're not allowed to discriminate based on, of course, gender, age, race, ethnicity, but also based on military activity, right, based on genomic information, based on pregnancy. You have similar requirements, similar rules that are already in the place around financial system, right? You're making a lending decision, if you're deciding, what interest someone should pay or what discounts you're going to give a consumer. To handle this, something Johnson Labs has been working on really for more than 2 years now is the LangTest library. And the reason we include it in this course is because it's a completely open source library. So also it's Apache 2.0 license, right? It's completely free, including for commercial use. It's a simple Python library. Also, it's not an API, it's not a product, just something that you run on your own machine, right? So you can run it on your own laptop, you can run it on your CI/CD server, right, as part of your test and release process. And the goal really is to have one simple framework that can automatically generate and run more than 100 types of tests. LangTest aims to basically add 3 steps in your kind of your AI or LLM model development. So instead of training the model, testing it locally, and then releasing the models, we say, look, we're going to do, like, there may be 3 more steps in this workflow. First of all, we're going to generate tests. And really, one cool thing we can do today is, because we have generative AI, you do not need to write all the tests the way we've, as software engineers, we've been taught to write unit tests, right? So it's not okay, let's write one test after the other and get to a point where we have, several hundred tests. You can say, okay, I want to test for bias, for example. I'm going to automatically generate several thousand tests, right? So for example, if I need to match resumes to job descriptions, okay, give me a resume. Okay, now let's see. Let's change the candidate's name, right, from a male name to a female name, and see if the ranking changes. Let's change it from a Hindu name to a Muslim name to a Farsi name to a Hispanic name, right, and see if that has an impact. Let's add a mention of that person's religion, right? Let's explicitly add their age on the resume, right, in some way, right, and see how the model reacts to that, right? The point is that all of those things we can now ask an LLM basically to do for us automatically. We can do it with bias, we can do it with fairness, we can also do it with robustness. We can add typos, we can change the orders of things, we can change synonyms automatically, and see really how reliable and robust the model is. Once we've generated tests, the next thing is we want to automatically run the tests. And LangTest enables you to run them across basically every kind of LLM kind of platform or API that's out there. So you can run it against any LangChain model, any Hugging Face model, right? Any OpenAI model, Johnson Labs model, Databricks model, and so on. You can do regression testing. So meaning run the same basically test suite, because there is a concept of a test suite, right? That is something that of course should be versioned and human readable. You can run it, you can compare it across multiple LLMs, you can compare it across multiple versions, right, of the same LLM over time. And then really you can be at the point where just like any other type of software, you have a test suite and you can check that all your tests pass, right, or at least pass a certain thresholds before you decide if the model is good enough to be released, right? And that's how you know basically that you're doing something that's legal, right, and that's allowed to run, even if you have a feedback loop or make changes. If your model has issues, there's also the ability to augment data, right? So in some cases, if you say, oh, you're underrepresenting, say, Hispanic people in your model, look, we can automatically generate augmented synthetic data, right, specifically, right, with those kinds of names or characteristics, and then you can try to retrain or fine-tune the model and run the tests again. So what you'll see is basically some of the different types of test types that LangTest offers, right, from robustness, accuracy, fairness, many different kinds of bias, accuracy, of course, and different data leakage, right? But overall, there are quite a few categories of tests with the goal of really enable you to build one comprehensive test suite that tests all aspects, right, of the model, including accuracy, but also covering everything else you need to have something you can call production grade. So that's an overview of what you're going to see today and tomorrow. And hopefully, this hour was useful to give you really some indication of, where things fit within the overall ecosystem. Now we're going to dive deep into each section, and look at some code. To get the most from this training, please do try the libraries and the tools, right? So, if you're talking, if you're showing a Colab notebook, just, get the notebook, load it, Colab within your own web browser, right, within your own account, try to run it, right, especially for the, for the open source tools are definitely something you can do. Ask lots of questions, right? You have access here to the people who actually build this technology and build this software. So please feel free to to ask and make use, right, of the experts that you have here. The third thing here, we are going to talk specifically a bit about how you use things. right? Here's the code, right? Here's the architecture, right? Here are the notebooks, here are the features, right? Here's how you run it yourself, here's how you change it. If you want, another thing that we're not going to cover here is really how this is used in real production use cases. And for that, if you go to johnsonlabs.com/customers, there are about 70 type public case studies, right, where companies have shown what they've learned, right, from trying to put the system in production. So there are a lot of good kind of really best practices and lesson learning for specific cases. And with that, we are exactly 1 hour since we started. What I would like to do now is have a 10-minute break. So we'll gather here at 1:15, back in 1:15, for the next section in this training. Thank you.